8.REI4 is solving quadratic equations, and I'm going to go through several different methods for doing that. One thing that we learned is on the TI-36X Pro we could use polysolve as long as your equation is in standard form like the one that they're giving here. Remember, in polysolve it'll ask you for your A, your B, and your C. In this particular quadratic, our A is 1, our B is 2, and our C is -8. And remember, it'll give you your x1 and your x2. And these are your solutions. So let's talk about the 4 different terms that we referred to when we talked about solving a quadratic equation. One term that we used was solution. We said, okay, the x1 and the x2 are considered our solution. We also refer to x1 and x2 as our x-intercepts. Remember, that's where the graph crosses the x-axis. Another way we referred to the solution is the roots. So x1 and x2 are considered our roots. And then another term, and all of these mean the same thing, is our zeros. So x1 and x2 are referred to as our solution or solutions, our x-intercepts, our roots, and our zeros. So if you don't have a TI-36X Pro calculator, I'm going to show you some other strategies that are really pretty simple for finding your x1 and your x2. So let's take a look at the first method. The first method would be by using a table or a graph. So for instance, if you were to create yourself a table, you could even plug this into your calculator and get a table that way, or you could just do it manually. All you have to do is pick some x values. Typically, it's a good idea to pick the same number of negatives as positives. I'm just picking some different values here around the origin. And when you plug those values into the quadratic equation, it will return for you the y values. So I'm going to finish up this table. And your zeros, or your x-intercepts, are what x is when y is 0. So you can think of it like this. So when I look at the table, I'm looking at an x-intercept here at -4, and then I also have an x-intercept or a solution at 2. And of course, if I were to graph this, here's what it would look like. And I'm looking for my symmetry, which is happening right here. So I know that I've got a vertex at -1, -9. And really all I need are those 3 points. So there's the graphical picture of my quadratic, and you can see right here where I'm highlighting our x-intercepts. So you can either look at where the graph crosses the x-axis, or you can go back and look at the table and see what x is when y is 0. And remember, you've got 3 possibilities. Your quadratic could have 2 real solutions, like in this particular case, might only have 1 real solution, or it's possible that it has no real solution. And in that case, it would have two imaginary solutions. All right, so let's look at the second strategy or method that we're going to be reviewing. It's called the square root method. And the quadratic that we're looking at is x squared plus 2x minus 8. What we need to know is that this method only works when your b is equal to 0. Only works when b equals 0. So notice in this case, your b is not equal to 0. Your b is equal to 2. So you can't use this method. Can't use the square root method. And we'll see some examples in just a little bit where your b is equal to 0 and you will be able to use this method, and we'll see how that process goes. All right, the next thing that we're going to look at is factoring. And we're going to take this quadratic and I'll show you how you can factor it. So what you want to do when you're factoring is set yourself up a T-chart. I'll do that off to the side here. And with your T-chart, you want to multiply your A times your C. And in this case, we said earlier A was equal to 1, B is equal to 2, and C is equal to negative 8. So my A times C is going to be negative 8. Now when you're factoring, you're looking for two numbers that are going to multiply to give you the negative 8, but that will add together to give you your B value, which in this case is a positive 2. So if I think about it, I could multiply 4 times 2 to get 8. And I want to be able to add them to get a positive 2, but to multiply them and get a negative 8 out of it. So it would work if my 2 was negative. 4 times negative 2 would give me the negative 8, and 4 minus 2, or 4 plus a negative 2, would give me a positive 2. So when you write your factors, you're going to have 2 sets of parentheses. There'll be 2 binomials where x is the first term in each binomial, and then the 2 numbers that you found over here are going to be the second values in that set of parentheses. And these are your 2 factors. In other words, if you were to FOIL these 2 factors together, you would end up with the original quadratic x squared plus 2x minus 8. Now to solve this, to find out what x1 and x2 are, you have to take each one of your factors and set them equal to 0 and solve. So I find out that my first x-intercept, my x1, is negative 4, and my second x-intercept, my x2, is a positive 2. And if you had plugged this into your calculator, you would have found x1 equals negative 4 and x2 equals 2. And one thing to point out is that not all quadratics are even factorable. So factoring doesn't always work. Sometimes when you do that T-chart, you can't come up with 2 numbers that multiply together to give you your A times C and add together to give you your B. So it's not always going to work. And if it doesn't work, we call that quadratic prime. If you've ever heard the term, prime quadratic, it's because it's not factorable. All right, the next one that we're going to learn how to do is the quadratic formula. Now the nice thing about the quadratic formula is it always works. You can always solve a quadratic using the quadratic formula. So what is the quadratic formula? The formula is negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So in this particular problem, and I'm coming back up here and looking at where I identified A, B, and C, use your parentheses. It's really important to use those parentheses when you're plugging this into your calculator. And you should get 2 answers out of it because of that plus or minus. All right, so coming over here, I get negative 2 plus or minus the square root of 4 minus a negative 32 all over 2. That gives me a negative 2 plus or minus the square root of 4 plus 32, which is going to give me a 36 all over 2. All right, so this is going to give me 2 separate solutions. I'm going to have a negative 2 plus the square root of 36, which is 6, divided by 2. That's going to give me one solution. And then I'm going to have a negative 2 minus 6 divided by 2. And we'll come down here to finish it up. So negative 2 plus 6 is going to be a 4 divided by 2, which is giving me 2. And then negative 2 minus 6 is a negative 8 divided by 2, which is a negative 4. And if you remember, those were the 2 solutions we found when we used factoring as our method. So we're getting the same values for x1 and x2 using a different method. All right, so let's come on down and focus first on graphing. So when you're going to solve by graphing, you need to identify your x-intercepts because that's what the solution is an x-intercept. So on the graph, you want to look for where the function crosses the x-axis. In a table, look for where there is a 0 in the y value. The x values for these coordinates are the solutions to the quadratic equation. More often than not, your x-intercepts on a graph are not whole numbers, so you must know all methods. This is really important. You must know all methods for solving quadratic equations to make sure that you are accurate in stating the solutions. So graphing is not a real good method when your solutions are not whole numbers. All right, so let's look at the first graph. This graph has 2 x-intercepts. You can see it crossing here somewhere between 3 and 4, and also here somewhere between 4 and 5. That's a perfect example of a graph that's not crossing at a whole number, so it would be difficult to get the exact value of the x-intercept by just looking at the graph. But one thing you do know is an approximation of the x-intercept, and you also know that if there are two x-intercepts, there are two real solutions in this case. In the second graph, notice that there is one x-intercept. It's only touching right here at -1. Therefore, there is one real solution. In the second graph, notice the graph doesn't cross the x-axis at all. So there are no x-intercepts, 0 x-intercepts, which means there are no real solutions, 0 real solutions. And another way to state that is that there are two imaginary solutions. Sometimes you'll hear that said. So I'll write that down. I don't want you to be confused if you see the terminology two imaginary solutions. That just means that there are no real solutions, which we sometimes refer to as NRS. If you look down at the table in number 4, we're looking for our x-intercepts. So you want to look at your y values and find where y is equal to 0. And then that's going to give you your x-intercept. Again, in number 5, look at your y values at where y is equal to 0, and that's going to give you your x-intercepts. So this one has one real solution, and this one has two real solutions. All right, so now let's take a look at the method of solving by taking square roots. It says this method works when the equation is in one of two forms. Case 1, the equation is missing a linear term. Another way to say that is that your b is equal to 0. So the first thing that you want to do is isolate your quadratic term, your x squared term. Once you've isolated your quadratic term, your x squared term, you're going to want to take the square root, I'll just call it square root, both sides of the equation to eliminate that square on that x. Always make sure that you put a plus or minus in front of the square root. Remember, every number has a positive and a negative square root. And then finally, from there, solve the square root if possible, or simplify it. So let's take a look at the first example. We've got 2x squared plus 16 is equal to 0. So the first thing I want to do is try to isolate that quadratic term, the x squared term. So I need to subtract 16 from both sides. I get 2x squared excuse me, is equal to -16. Now I want to further isolate that x squared by dividing out the 2. And I get x squared is equal to -8. Now the opposite of squaring something is to square root it. So I'm going to square root both sides. And remember, when you do that, you need to put a plus or minus in front of that square root. So the square root of x squared becomes x, and now I'm going to have plus or minus the square root of -8. If you'll recall, you can't take the square root of a negative number. In other words, there's no way that you can square a negative number and get a negative out of it. So in this particular problem, because we've ended up taking the square root of a negative number, we're going to have an answer of no real solutions. So this would be an example of a quadratic that is either turned up above the x-axis or turned down below the x-axis. It's not crossing the x-axis. Now, what if we took this same problem but just changed it up a little bit? So we'll let this be example 1, and we'll create an example 2. And in example 2, we'll have 2x squared minus 16 is equal to 0. We'll take the same approach. We'll add 16 to both sides to try and isolate the quadratic term. We will divide out 2 on both sides to get x squared is equal to 8. And then we'll take the square root of both sides, so x is equal to plus or minus the square root of 8. If you'll remember from our work with simplifying radicals, we can take 8 and break it down a little bit further by prime factorization. 8 is 2 times 4, and 4 is 2 times 2. You have a 2 of a kind, so you can take out a 2, and then this other 2 has to stay up underneath the square root. So you have 2 solutions. You have x is equal to positive 2 on the square root of 2, and also x is equal to negative 2 on the square root of 2. So this is a situation where you had 2 real solutions. All right, let's look at another possibility. Sometimes you'll see a quadratic in vertex form, and you know what vertex form looks like. Let's write it off to the side. Vertex form looks like a times x minus h squared plus k. Well, you can use solving by taking square roots. You can use this method when your quadratic is in vertex form. So for your steps, you want to isolate the set of parentheses. Then you're going to want to square root both sides. So it's the same steps that we took earlier. Square root both sides. Make sure you put the plus or minus in front of that square root. Then you're going to want to simplify that square root if it can be simplified any further. And then one additional step that you'll have in this particular example that we didn't have in the previous examples is to solve for the x. And I'm going to work a problem so you'll have a chance to see what it looks like. So here's an example of a problem that's in vertex form. The first thing I want to do is to try to isolate the parentheses that are being squared. So before I can divide out the 2, I need to add 4 to both sides. So I've got 2 times x minus 3 squared is equal to 4. Now I can divide out that 2 because I need to isolate the parentheses. So that'll get rid of the 2 on the left, and I'll have x minus 3 squared is equal to 4 divided by 2, which is 2. The opposite of squaring something is to square root it. You have to do it to both sides. So the x plus 3 comes out of the square. Basically, that square root cancels with the square. So I have x plus 3 is equal to plus or minus the square root of 2. And the square root of 2 cannot be simplified any further, so I'm going to leave it like that. But I've got to solve for x, so I'm going to subtract 3 from both sides. And I'm going to get x is equal to, and you can write it several different ways. You can put that negative 3 in front of the plus or minus 2, or it would be perfectly fine to write it as plus or minus 2 minus 3. Just make sure that you can tell the minus 3 is on the outside of the square root. I prefer for the rational number to be in front of the irrational number, which is this particular format right here. So I like for it to be in what I call A plus BI, or maybe another way to say it is A plus root B format. Your rational number goes first, and then remember we said a square root is an irrational number, so we'll put that second. All right, let's come on down and look at the next method, solving by factoring. So this is the process that I like to use, that some people have different formats or ways of factoring. I'm going to show you a method called grouping. And you really only need to use grouping when your A is not equal to 1. I'm hoping on some of these that if A is equal to 1, I'll be able to show you how to use a process other than grouping. So let's look at problem number 1. I'm always trying to factor out a GCF whenever I possibly can. I notice that all of these numbers are even, so they're divisible by 2, but we want to make sure they're not divisible by 4. I know 34 is not divisible by 4, so I definitely can't pull that out as a GCF. But I definitely can pull out the 2. You want to pull out the biggest common factor that you can. So I'm going to be left with a 2x squared plus 16x plus 21. All right, so now I'm looking at a quadratic, 2x squared plus 16x plus 21. Notice my A is not equal to 1. So I'm going to do a process called grouping. I'm going to use the T-chart that I showed you earlier, where you put the A times C on top of the T-chart. So in this case, my A is 2 and my C is 21. So that's going to be 42. Now I'm looking for two numbers that when you multiply them together, you get 42, and when you add them together, you get 16. I'm going to use my calculator, build myself a table, and see if I can identify two numbers that will multiply together to give me 42 and add to give me 16. Unless I did something wrong. I see what I did wrong. Right here, 34 divided by 2 is 17, not 16. So now it looks like instead I'm wanting two numbers that multiply together to give me 42 and add together to give me 17. So that might help me find it. Let's see. And I found it, 14 and 3. So 14 times 3 gives me a 42, and also adds together to give me that 17. So that'll work. So here's what I'm going to do. I'm going to ignore the 2 that's the GCF right here on the outside. I'll ignore it for now, but I will eventually put it back on the outside of my factors. So I'm going to write the first term, which is 2x squared, and instead of writing the middle term 17x, I'm going to write it as two terms, a positive 3x and a positive 14x, and then keep that positive 21. The reason I'm doing this is because grouping only works when you have 4 terms. So we might want to make a note over here where I talked about grouping and say that you must have 4 terms. So what I was trying to do was basically take that one middle term and write it as 2 separate terms that add up to be the middle term. Then what you do for grouping is you group the first 2 parentheses together, or excuse me, the first 2 terms together in a set of parentheses, and you group the second 2 terms together in a set of parentheses. And you pull out a GCF in each different group. So in the first group, I'm going to pull out an X. That's what's common between those 2 terms, and I'm left with 2x plus 3. In the second group, I can pull out a 7 because that's common between those 2, and I'm again left with a 2x plus 3. And you know you've done grouping correctly when you get these 2 factors in parentheses that are identical. They have to match each other. If they don't, then you know you've done something wrong. So in your final factors, you write one factor that was the repeat that you got, the 2x plus 3, and then the second factor is these 2 GCFs that you pulled out. You put those together in a set of parentheses. And there are your 2 factors. And then to finish the process, you set each of those factors equal to 0 and you solve. And don't forget to bring down that 2. So I'm going to take the first factor, which is 2x plus 3, and set it equal to 0. When I solve it, I get that x is equal to negative 3 halves. So that's going to be one of my solutions for this one. And then if I take the x plus 7 and set it equal to 0 and solve, I get x is equal to negative 7. So those are my 2 solutions that I solved by grouping. In problem number 2, notice that I don't have a c value. C is equal to 0. These are probably the easiest problems to solve. And make that look a little bit better. I don't know if that's how you spell easiest. Why don't I just use the word easy? The reason they're so easy to solve is because you don't have to do the factoring by grouping like I did in problem number 1. All you have to do is pull out a GCF. And if you look at both of these terms, it looks like I can pull out a 2x. 2x will go evenly into both of them. So we're going to pull out a 2x. I'm left with a 2x plus 11. And now you have 2 factors. You have the 2x and you also have the 2x plus 11. Set each of those factors equal to 0 and solve. I get x is equal to 0 for one of my solutions, and then for the second solution I get 2x equals negative 11. X will equal negative 11 halves. So these are definitely the easiest problems to work. All right, let's look at problem number 3. What you want to do when you're factoring is get all of your terms on the same side. So I'm going to subtract 1 from both sides, and I'll have 49x squared minus 1 equals 0. Now this is an example where you have a difference of squares. In other words, your first term is a perfect square and your second term is a perfect square. Let me show you what you do when you have a difference of squares. You actually can factor it very easily. You take the square root of the first term, and the square root of 49x squared is 7x, and you put that as your first term. Then you take the square root of the second term, which would be 1, and then you just alternate the signs. And there are your 2 factors. And again, you set each factor equal to 0 and you solve. So one of my solutions is negative 1/7. And the other solution is going to be positive 1/7. Looking at problem number 4, we're going to have to get all of our terms on the same side and write it in standard form. So I have 4x squared minus 20x plus 25 is equal to 0. I can't pull out a GCF. There's not a number that'll go evenly into 4, 20, and 25. So we're going to be dealing with some big numbers. I'm going to go ahead and do my T-chart. I have A times C, 4 times 25, which is 100. And I'm looking for two numbers that are going to multiply together to give me that 100 and then add together to give me negative 20. Well, what about 10 and 10? That would multiply to give me 100. And if both of these numbers are negative, negative 10 minus 10 would give me the negative 20. So to use grouping, remember I have to write the first term. I'm not going to write the second term. Instead, I'm going to break it up into the two terms that I just found from over here in the T-chart. And then I'm going to keep the last term. Put parentheses around the first two terms and around the second two terms. Pull out a GCF in each grouping. Let's pull out a negative 5 here, and we'll have a 2x minus 5 again. We feel good because we got the same binomial in each set of parentheses, so that's going to go in your first factor. And then in the second factor, you're going to put these two GCFs together. And then don't forget, we've got to set each one of these factors equal to 0 and solve. Now, since both of these factors are the same, you're obviously going to get the same value for each x. That means in this case, you really only have one real solution. This is an example of a quadratic that just touches the x-axis in one place. All right, let's look at the last one. We've got to get our terms on the same side. And let's add 10 as well. So we end up with 4x squared plus 3x plus 10 is all equal to 0. I don't have a GCF that I can pull out, so let's do our T-chart. A times C is going to give me 40 on top. Two numbers that multiply to give you 40 and add to give you 3. How about, yeah, 8 and 5 is not going to work. Let me go into my table just to make sure. It's almost looking like it's not going to work. This might be an example of a problem that is not factorable. I'm going to double check just to make sure. Sometimes doing the table in your calculator or writing down all the numbers that multiply together helps a little bit. I don't see how I can get a positive 40 but also get a positive 3. Because if I did 8 and negative 5, that would give me a positive 3, but when I multiply them, it would give me a negative 40, not a positive 40. So I don't see any options here I'm going to say that this is an example of a quadratic that is prime and is not factorable. But I will tell you one method that would work for a prime quadratic, and it's quadratic formula. The nice thing about a quadratic formula is it works for all quadratics. So if you get really comfortable with the quadratic formula, you can always use it. All right, so here's the formula. The one thing that I would change is add in the parentheses. If you don't, you could get into some trouble when you're plugging this into your calculator. Your calculator may not do it properly. So let's come on down and look at the two examples that we have. Just like with factoring, you want to get all of your terms on the same side. So I'm going to add x to both sides here. So I'll have 2x squared plus x minus 3 is equal to 0. It's important to accurately identify A, B, and C, and then just plug it into your quadratic formula. So we'll have a negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So I've got a negative 1 plus or minus the square root of 1 minus 4 times 2 is 8, and 8 times negative 3 is a negative 24, all over 4. And you can plug this into your calculator, but I want to show you how easy it is to just do it by hand. So here you've got 1, the negative of a negative becomes a positive, so 1 plus 24, which is 25. And that's going to be nice because 25 is a perfect square. So we end up with two solutions here. We have a negative 1 plus the square root of 25, which is 5, all divided by 4. And then we also have a negative 1 minus the square root of 25, which is 5, all over 4. So a negative 1 plus 5 is 4, and 4 over 4 is equal to 1. So there's one solution. And then negative 1 minus 5 is a negative 6 over 4. That's going to reduce to a negative 3 halves for our second solution. All right, let's see if I can make enough room for problem 2. A is 4, B is 3, and C is 10. Let's see if I can write a little bit smaller. So I'm going to have a negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So negative 3 plus or minus the square root of 3 squared, which is 9, minus 4 times 4 is 16 times 10 is 160. All over 8. And then I get x is equal to negative 3 plus or minus the square root. Well, what is 9 minus 160? Hopefully you can already see that that's going to be a negative number. I'm getting negative 151. Now, what does that mean when you are trying to take the square root of a negative number? It can't be done. So immediately when you see that, you're going to write the answer, no real solutions. And if you were plugging this into your calculator on your TI-36X Pro, it would give you a domain error, and you would know then that you had no real solution. All right, so let's look at finding a discriminant. So a discriminant is a formula for finding how many solutions you have. And you can use this formula and you'll recognize it because it's a part of the quadratic formula. It's not the entire quadratic formula, but it is a part of the quadratic formula. And it'll give you the information that you need and a way to determine whether you have two real solutions, one real solution, or no real solutions. Okay, so the standard form of a quadratic equation we know is, and I'll put y equals ax squared plus bx plus c. And the formula for the discriminant, like I said, you'll recognize is b squared minus 4ac. And again, I would put parentheses the same way you do in the quadratic formula. So when you do b squared minus 4ac, if you get a number that is equal to 0, that tells you that you have one real solution. Does that look like an R? If not, let me make it look a little bit more like an R. There you go. If you find out that your value is greater than 0, that is telling you that you have two real solutions. And then finally, if you find a value that is less than 0, that tells you that you have no real solutions. And remember, another way of stating that is you have two imaginary solutions. And so we've got pictures here showing one real solution, two real solutions, and no real solutions. All right, so let's see how this works. So they're giving us a quadratic equation, x squared minus 4x plus 4, and let's go ahead and graph it. So if you'll recall, you can use a formula where h is equal to negative b over 2a, or you can just use polysolve on your calculator and find your h and your k that way. So in this case, my a is 1, my b is negative 4, and my c is positive 4. So for h, I'm going to have the negative of negative 4 over 2 times 1. So working it down, the negative of negative 4 is positive 4 over 2. That gives me an h of 2. And then the way to find your k is to take that 2 and plug it into the original quadratic. So x squared minus 4 times x plus 4. And I'm going to just plug that into my calculator to make it a little bit faster. And I'm getting k is equal to 0. So 2, 0 is my vertex. Then, if you've seen me talk about graphing quadratics, the easiest way to do it is to go 1 unit to the right of the vertex. In this case, it would be 3, x equal to 3, and plug that into your equation and see what you get for y. So let's see what happens when we plug in a 3. I mean, basically on my calculator, just go right back up and replace that 2 with a 3. and I'm getting 1. So 3, 1 is a point, and then use symmetry to get the other point, 1, 1. And then that gives you your graph. And we can clearly see that this quadratic has one real solution by graphing it. All right, now let's use the discriminant and see if we can find that there was one real solution. So we found that in the quadratic, our A was 1, our B -4, and our C +4. So we're going to use the discriminant formula, B squared, notice I'm using the parentheses, minus 4 times A times C. And I'm getting -4 squared is a +16 minus 4 times 1 times 4 is 16, and 16 minus 16 is 0. And if we look back at what we said earlier about the discriminant, we said that if your discriminant is equal to 0, then your quadratic has one real solution. All right, so that concludes our review of solving quadratic equations and also using the discriminant to identify the number of solutions that your quadratic has.